Hello boys and girls, Mr. Giomini. I want to come to you a little bit of examples for lesson 5-7 scale drawings. Take a look, kind of pulling up some things from the evening practice. Now, kind of didn't really get into this too much today, and I know I've kind of helped a couple of you. There's a couple ways to look at this. Now, the scale factor, talk about scale factor. I always think about the scale, and we're going to make a ratio here. We have the scale to the actual. Now, what do you mean by scale is, and I don't know how many of you still make model cars, or people even do that anymore, or trains. Maybe dad or somebody, grandpa puts a train on the Christmas tree or something like that. So the scale is that train. That's the smaller version of the actual thing, and I like to call the actual thing the real thing, if you want to think about that. Or how many of you do Legos? You do Legos. Legos are the model, if you want to think about it, the model to the real. When I go up here to number 1, we have a bear and a stuffed animal. Now, obviously, I think we all know which one's the scale, which one's either the smaller version or something or the larger. Sometimes you make a larger version of a cell. You've been doing it in science, looking at analyzing cells. Well, we're not going to make a cell the same size or make it smaller, actually make it a larger one so we can see it and see the details of it more vividly. Well, in this case, we have the stuffed animal, and that's our scale model over our actual, which is the real bear. So I'm going to put on top 15 and a half, 15 and 5/10 over 62. Now, I always want to try to simplify this. So usually scale factors, we want to get it to a 1 to something ratio. So we almost want to look for a unit rate if you want to think about that. So what I'm going to do is I'm actually going to do a little division. I'm not going to divide 15 and a half by 62. I actually want to divide both by 15 and a half. I want to get that top one to a 1. So to get that to 1, I need to divide by 15 and a half. So I'm going to take my calculator here. 15 and a half divided by 15 and a half, that gives me 1. 62, let me pull this over. 62 divided by 15 and a half equals 4. So we have a 1 to 4 scale factor. For every, if you want to think about it, for every 1 inch the stuffed animal is, the actual real bear is 4 inches. So if I were 1 inch tall, if I made a little bobblehead doll of me, for every 1 inch that the bobblehead doll is, I am actually 4 inches in real life. Let's look at the airplane and the model. Now, this is pretty easy to see which one is the model, which one is the actual. So I take a look. My model, I'm going to do my scale, or my model to my actual. I'm going to go 1 5/10 is my scale, or my model, over 25 and a half. Okay, now remember what I said, I want to get this to a 1 to something ratio, so I'm going to divide both by 1.5. So for every 1 foot on the scale, we'll figure out how long the actual airplane is. So divide 1.5 by 1.5 is 1. 25 and a half divided by 1.5 equals 17. So we have a 1 foot. So the model airplane, for every 1 foot the model airplane is long, it's actually 17 feet long in real life. Let's take a look at some other ones here. Let's look at number 7. We have the actual dimensions and we have the model dimensions. And it tells us up top in the directions that, where's my highlighter? The scale factor of each model is 1 to 16. Oop. 1 to 16. What that means is for every 1 inch or 1 foot, or whatever we're using here, 1 to 16. So if it's 1 inch on the model, it's actually 16 inches in real life. If it's 1 inch or 1 foot on the model, it's actually 16 feet in real life. So that's the ratio I'm going to start with all these. Now I just make my proportion. So look at the bookcase. Now the actual height of the bookcase is 96 inches. So what I'm going to do is come over here. I'm going to go 96 inches goes on the bottom because that's the actual. If I want to think about it, scale over actual. We don't know how tall the model is. Now we have a proportion. Cross product, 96 times 1, that gives me 96, is equal to 16 times x. I will divide both sides by 16 because I want to evaluate for 1x, not 16 x's. X is equal to 6. And they don't really, and I'm going to go 6 inches here. So if we have this bookcase, the model is 6 inches. If I'm making a model of it to show a customer because they want some bookshelves, I'm going to make a model. And I'll say, hey, look, for every 6 inches on this, we actually have 96 inches in real length. let's look at the car. Now, this one they have length and length, height and height. Well, we know that the length is going to have a 1 to 16 ratio. The height is also going to have a 1 to 16 ratio. So let's look at the length first. We don't know the length of the model, but we do know the length of the real car is 13 feet. So again, we'll do cross products. 13 times 1 is equal to 16 times x. I'll divide both sides by 16. So I get my calculator out. 13 divided by 16 equals, okay, so that means for every, it's kind of an odd one here. So for every 13 feet of length I have in the car, I actually have less than a foot of length on my model. And then I would do the same thing for my height. Now the height of the car, and again, I'm going to use the same ratio. I can use 16 to 1, or 1 to 16, excuse me. I can use that same thing. And now, again, I'm comparing the scale to the actual. Well, they give me the dimensions of the actual height of the car. This is the scale. We don't know the actual height of the scale model, so we'll put an H there. This is 5.5. So now I have 5.5 equals 16 times h, divide both sides by 16. I have, get my calculator out, 5.5 or 5 5/10 divided by 16 equals, okay, so that means the height of my car is, oops, now this is my scale model, all right, so it's about 1/3 of a foot. This was as close to a foot. Okay, hope that helps you out. Have a great one. We'll see you guys soon. Bye-bye.